Welcome back. This is it. You've made it. It's section 10. It's the last section, and it's called Introduction to Integers. This is going to be our first unit in 7th grade, so we wanted to give you guys a little bit of a head start. Technically, an integer is a positive or negative whole number. In our first unit, you'll learn how to add, subtract, multiply, and divide integers. For right now, though, we're just going to focus on the rules for addition. You'll learn the rest very soon. There's 2 rules for addition. The first rule is when both of your numbers have the same sign, meaning they're both positive or they're both negative. In which case, you're going to just add the digits together and keep the sign the way it is. So, for this particular section, I'm going to use 2 colors. I'm going to have red representing negatives and green representing positives. So for our first example, we have a -8 plus a -9. So 8 negatives plus 9 more negatives. Don't you just see a bunch of red dots? Add them all up. There's 17 red dots, and since the red is negative, it means negative 17. Or look at the rule. Add the digits together and keep the sign. 8 plus 9 is 17. Since they were both negative, our answer is negative. So look at the next one. Very similar, except both of these digits are positive. So I'm going to use green. 8 positives added to 9 positives. Now you see a bunch of green dots. 17 of them, as a matter of fact. So that means the answer to 8 plus 9 is a positive 17, and we don't need a little positive sign. Just 17 will work. Mrs. Trombley is going to take care of the next 2.
All right, our next example, we have -4 plus another -4. I'm going to get my red marker for negative. So I would represent -4 with 4 red dots, another -4 with 4 red dots. All together, we have 8 red dots. That means we have -8. And again, 4 plus 4 is 8. The answer is negative because the signs are both negative. Final example for this, -7 plus -8. So this -7 means I have 7 red dots. -8 means I have 8 red dots. When you add them all together, we have a total of 15, and they're all red, so 15 negatives. 7 plus 8 is 15. A negative plus a negative will always be a negative. All right, in our next example, we're going to take a look at when the signs are different, meaning you have one positive and you have one negative. The rule for this is not the same. With this, you actually have to subtract the digits, and you take the sign of the higher digits. You're taking the sign of whatever you have more of. If you have more positives, your answer will be positive. If you have more negatives, your answer will be negative. I know it seems weird that it's an addition problem and you subtract, but hopefully this will help it all make sense. So in our first example, we have a -4 plus a positive 5. I would represent the -4 with 4 red dots, and a positive 5 would be represented with 5 green dots. Now in the past, in the examples above, we just added them all together and we had all of the same. But in this, if I add them all together, I don't have 9 red and I don't have 9 green. I have a mixture of each. Something you need to know, I don't know if you've heard the term zero pair before, but if you put together a negative and a positive, they're called a zero pair because when you add them, guess what you get? 0. So this -1 and this positive 1 would cancel out. They would become 0. And this negative and this positive, and this negative and this positive, and this negative and this positive. And you can kind of see this lonely green dot that's left over. That's our answer. Our answer is a positive 1. I need to put that in green just because that's how I am. All right, so again, if you take a look back at the rule, it says subtract the digits and take the sign of the higher digit. 5 minus 4 is 1, and the higher digit is positive, so my answer is positive. So that's how the rule works. All right, next example, -9 plus a positive 4. -9 is going to be represented with 9 red dots. Positive 4 we can represent with 4 green dots. Again, we're going to make all of the 0 pairs that we can. So for every negative and positive that match up, they can cancel out. So those 4 negatives cancel out those 4 positives. When you take a look at what's left, we have 1, 2, 3, 4, 5 negatives left. And again, 9 minus 4 is 5. The higher digit is negative, so my answer is negative. Ms. Sullivan's going to take over for these last 2.
All right, we have a -6 being added to a +6. So if I color code these, I'm going to first make 6 red dots and 6 green dots. And you might be already knowing what the answer is here. It's kind of like if you lost $6 and then found $6, you break even, which means you end up with nothing. So what we have here is just a bunch of 0 pairs. If I take every negative with its 0 pair on the positive side, everything gets crossed out, which means you are left with a big fat 0. And if you look at the rule, subtract the digits. What's 6 minus 6? It's 0. Which digit is bigger? Neither one. So there's no value at all. So that's why I'm writing that one in purple. It's just 0 for our answer. All right, last one. Drum roll. This is it.
Woo!
This is it. Our last problem of the summer. Positive 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 negatives. 1, 2, 3, 4, 5. All right, I'm going to get rid of my 0 pairs. So 5 positives would cancel out these 5 negatives, and I'm literally left with 5 positives. 10 minus 5 is 5, and the bigger digit is 10, which is positive, and our answer is a +5. Gosh, I feel like we already know you. You already know us. I feel like we need like a party or something, but instead of partying, how about you just do section 10 and we'll see you on the first day of school?
See you soon. Have a great rest of the summer.